Hi, welcome to Algebra 2 Common Core. In this lesson, we're going to learn about multiplying and dividing rational expressions. In example number 1, we want to simplify the product that is shown here. Now, this first example is one that you would have seen probably many years ago in middle school. 6/8 times 10/3. Normally, when we're multiplying, we would just multiply our numerators together and then multiply our denominators together. But then our product could possibly be reduced. So we could start by reducing, that is, looking for common factors in the numerator and denominator of each fraction. So for example, I see that 6 and 3 are both divisible by 3, so I'm going to cancel and make 6 divided by 3 equal 2. 3 divided by 3 is equal to 1. Going the other direction, 8 and 10 are both divisible by 2, so 8 divided by 2 is 4, 10 divided by 2 is 5. Now I could actually make one more division here because I see that up and down 2 and 4 can be reduced. So go ahead and cancel. 2 goes into itself once, 2 goes into 4 two times. So my final answer is going to be 5/2. Notice that all I've done is after I've canceled, I've multiplied my numerators together, multiplied my denominators together. And my reduced expression should be 5/2. Now, it's going to get a little bit more interesting when I have polynomials in the numerator and denominator. So in example B, x squared minus 4 can be factored into x plus 2 times x minus 2. The denominator of the first fraction, x squared minus x minus 6, that's going to be factored into x minus 3 times x plus 2. For the second fraction, the numerator, I can factor out a greatest common factor of 3x, and I'm left with x plus 5. And my second denominator, I can factor out a greatest common factor of 6x, and I'll be left with x minus 2. So now I'm looking for common factors in the numerator and denominator. It doesn't matter whether I'm canceling in the same fraction or whether I'm canceling a numerator of one fraction with the denominator of the other. So for example, x plus 2 will cancel with x plus 2. X minus 2 will cancel with x minus 2. Each time I'm canceling, I'm dividing by that binomial, x minus 2, so I'm really just getting a result of 1 in each case. The only other place that I can cancel, 3x and 6x can both be divided by 3x. So 3x divided by 3x is 1, 6x divided by 3x is 2. So the result of this multiplication in the numerator, I'm left with all ones. So 1 times x plus 5 is x plus 5. And the denominator, I'm left with x minus 3 times 2. I can distribute that and say 2x minus 6. Or I would also be okay leaving it as x plus 5 over 2 times x minus 3. Now, please don't be tempted to look at this x and say, oh, can't we cancel that? We can't because it's part of a binomial that's being added or subtracted to another term. So my final answer is one or the other of these two expressions because they are equivalent to each other. So take a few minutes to write in the box in your notes. When I'm multiplying rational expressions, step number 1 is if I've got any polynomials in the numerator or denominator, I should factor those polynomials first. Then I look for like factors that can be canceled. Once I've done the cancellation, then I can go ahead and multiply the numerator terms together and the denominator together. Let's practice with a few more examples of multiplication. In example number 2a, I see I have all monomials in the numerator and denominator, so I'm just looking to cancel any like terms in the numerator and denominator. So for example, 6 and 8 can cancel because I can divide them both by 2. So I'm getting a 4 and a 3. 5 and 10 can cancel because continue to cancel with your variables. So I see that y to the 7th and y to the 3rd would have a y to the 3rd in common. So I'm going to cancel those off, and that would leave me with an extra y to the 4th in the numerator. X squared and x to the 3rd would have an x squared in common, so I'm going to cancel those, and I'm going to be left with an x in the denominator. So in the numerator I have left 4 times 2, which is 8, y to the 4th. In the denominator, 3 times x, 3x. Take a few minutes and try example B and come back and check your answer with mine. My solution is 5 over 3x to the 7th, y to the 4th. Let's go on to part C, where we're going to factor these polynomials. So in the numerator of the first fraction, I've got 2x times x plus 6. The denominator, 4 times x plus 2. Second numerator, x minus 6 times x plus 2. And denominator, x plus 6 times x minus 6. And again, it's really important to note that I cannot do any cancellation back here at the original step. I can't look at this and say, oh, let's cancel an x squared with an x squared. I can only cancel things that are being multiplied together. So that allows me to cancel x plus 6 with x plus 6, x plus 2 with x plus 2, x minus 6 with x minus 6, and then 2 and 4 can both be divided by 2, so the result should be x over 2. Let's try part D. Factoring 9 minus x squared, make sure you do this in the right order, 3 plus x times 3 minus x. The denominator should be 2x squared as a GCF, and I'm left with x minus 3. My next numerator, 4x times x minus 1. Denominator, x plus 3 times x minus 1. Go ahead and do cancellation. X minus 1 cancels with x minus 1. X plus 3 is exactly the same as 3 plus x, so they can be canceled. 3 minus x and x minus 3 are negatives of each other, so I have to, when I cancel those, I have to include a negative 1 as an extra factor. And then 2 goes into 4 2 times. X and x squared can both be divided by x, so I'm left with an extra x in the denominator. So my final answer should be the negative of 2 over x. Let's look at example number 3. If the length of a rectangular garden is represented by 4 minus x squared over 3x squared minus 12x, and the width is represented by x squared plus x minus 20 over x squared plus 3x minus 10, find a rational expression for the area. So when I'm talking about a rectangle, I know that area is equal to length times width. So in this case, to find the area of our garden, we're going to say the length is 4 minus x squared over 3x squared minus 12x. That has to be multiplied by the width, x squared plus x minus 20 over x squared plus 3x minus 10. Continuing on, I'm going to factor all polynomials, so 2 plus x times 2 minus x. Let's look at the denominator. 3x is a GCF, and that leaves me with x minus 4. X squared plus x minus 20 would be x plus 5 times x minus 4. And x squared plus 3x minus 10 should be x plus 5 times x minus 2. So we've got to remember all of our factoring techniques from the beginning of the year. Go ahead and do some cancellation. X minus 4 cancels with x minus 4. X plus 5 cancels with x plus 5. And 2 minus x and x minus 2 are negatives of each other, or opposites, so I'm going to include that negative sign. So my final answer, the negative of 2 plus x over 3x. I can put that negative in front of the whole fraction, or in front of just the numerator, or in front of the denominator. Let's move on to the operation of division. So there's just one extra step that we have to do when we're dividing rational expressions. Our first step is going to be, let's change the operation to multiply and change the second fraction to the reciprocal, because dividing by a fraction is the same as multiplying by the reciprocal. So we'll continue on like we did with multiplication after we've done that original step, and we will factor all the polynomials and look for like factors to cancel. And then whatever's left in the numerator will multiply, and whatever's left in the denominators will multiply. So looking at our first example in exercise 4, 15x squared over 6y to the 5th divided by 5x to the 8th over 2y to the 7th. My first fraction stays exactly the same. You might remember this from middle school as the keep, change, flip operation. So we're keeping our first fraction, we're changing the operation to multiply, and we're taking the reciprocal of the second fraction. So 2y to the 7th over 5x to the 8th. Now it's just a multiplication problem, so we can go ahead and do our cancellation. We don't have any polynomials here. So 5 and 15 can both be divided by 5, so that gives me a 3 and a 1. 2 and 6 can both be divided by 2, so that gives me a 1 and a 3. And additionally, we can cancel off the 3's and just get a 1. Now I'm also going to cancel my x's. X squared and x to the 8th have an x squared in common, so that gives me an x to the 6th in the denominator. Y to the 5th and y to the 7th have a y to the 5th in common, so I'm going to end up canceling and getting a y to the 2nd in the numerator. So look for anything left over in the numerator. That's going to give me a y squared. In the denominator, I've only got 1 times x to the 6th. So my final answer turns out to be y squared over x to the 6th. Now pause the video for a few minutes and please do exercise B, and then come back and check your work. My answer is y to the 4th over 2x squared. So you can see that we did quite a bit of cancellation with the numbers, and then with the x variables and the y variables. Now let's see what happens when we have polynomials. I'm going to take the second step as I also do the keep, change, flip part. So x squared plus 2x minus 8, let's factor that right away into x plus 4 times x minus 2. So notice that the first fraction stays the same. I just want to go ahead and factor. The denominator 8 times x minus 2. I'm going to change to multiply and take the reciprocal of the second fraction. So that moves the 2x plus 10 to the numerator, so let's factor that into 2 times x plus 5. And the denominator x squared minus 16 would factor into x plus 4 times x minus 4. So canceling off like factors, x minus 2 cancels with x minus 2, x plus 4 with x plus 4, and 2 and 8 can both be divided by 2. So the result should be x plus 5 over 4 times x minus 4. Now take a few minutes and try exercise D and come back and check your work with mine. My answer is x minus 7 over negative 5. You'll notice that I did have a pair of opposite factors, 3x minus 1 and 1 minus 3x. For the last one, I want you to go ahead and do the you try it. This is a multiple choice, so pick which multiple choice answer you're getting, and then come back and check your answer with mine. I got choice 2, 3 times x minus 5, which is 3x minus 15. Check your factoring with mine and your cancellation and see if you got the same result. If you have any questions, please come in and see me in the morning. Thanks for working on multiplication and division tonight, and we'll do some more practice in class. Have a great night. Bye-bye.